this lesson, I'm going to give you an overview of the different components that make up the NetApp storage architecture. I'll be going into much more detail on each of these in later lessons, but because I'm going to be discussing them throughout the course, I want you to have an understanding of them now and know what the different terminology is. So at the bottom level of the storage architecture, we have our physical disks, our hard drives. Our disks get grouped into aggregates. So an aggregate is a set of physical disks. One of the attributes of our aggregates is the RAID group, how the RAID configuration is configured on there. If you look in the GUI in System Manager, you'll see that there's a page for disks where you can view all of your disks, and there's a page for aggregates where you can view your aggregates and you can configure them. There's not a page for RAID groups. The reason for that is that your RAID groups are an attribute of your aggregates. So your RAID groups are configured on the aggregate page. The next level we have moving up is our volumes. Volumes are the lowest level that clients can access their data at. So you could share a volume and then a Windows host could map a drive to that volume. So to summarize those three, your disks and your aggregates are physical resources. Then you have your volume, which is a logical resource on top of that. You could have multiple volumes in the same aggregate, or maybe just one volume in the aggregate. Moving up the next level above that, we have our Qtrees. They're called Qtrees because the main function of them is to configure quotas. So you could limit the total size of a Qtree or limit the amount of space that a user or group can use. You know, when I talked about volumes, I said that you could share a volume and then a Windows host could map a drive to that volume, or a Linux host could map to it as well. If you configure a Qtree, your Qtree goes in your volume and your Qtree will show up to your clients as a directory in that volume. They could also map directly to the Qtree as well if you wanted to share that. The last component we have in the storage architecture is our LUNs, our logical unit numbers. A LUN is specific to SANs, and it's the storage container that they are going to use for their storage. The LUNs can either go in a Qtree or they can go into a volume. So you can see the different components build on top of each other. We need to have our physical disks. Our disks get grouped into aggregates. For our clients to be able to access data, we'll configure a volume which goes in the aggregate. And optionally, we can configure a Qtree, which will show up as a directory in the volume, so it goes in the volume. And lastly, if we're using SAN protocols, we'll need to configure LUNs. Our LUNs either go into a Qtree or into a volume. So the mandatory components that we have are the disks, aggregates, and volumes. Qtrees are optional, and LUNs are for SAN protocols only. You wouldn't have LUNs if you were using only NAS protocols. The other storage architecture component I want to tell you about now is storage virtual machines, or SVMs. These used to be known as vServers, but they were renamed to SVMs in a more recent version of the operating system. So storage virtual machines and vServers, they both mean exactly the same thing. If you're working in the GUI now, you'll see they're listed under storage virtual machines. If you're doing your configuration in the command line, they're still called vServers there. The reason that we have storage virtual machines, say that you've got two different departments, Department A and Department B, and they want to have their own separate secure storage. In the old days, what you would have to do is buy two completely separate, physically separate storage systems, and you would require separate supporting infrastructure for them as well, separate switches. So this would be pretty expensive. What you can do with NetApp now and with the storage virtual machines is you can have one physical storage system, but you can virtualize it into separate logical storage systems, which are kept secure and separate from each other. When you do configure SVMs, down at the bottom level, our physical resources, our disks and our aggregates, they are still shared throughout the entire cluster. The reason for this is if we had dedicated aggregates, maybe the aggregate for department A is pretty empty and the aggregate for department B is getting really full. If the aggregates were dedicated at the SVM level, you would have to go and buy more disks for department B, even though you've got spare disks on department A. So that's why the aggregates are a shared resource. It means we get the most efficient use of our capacity. For configuring our SVMs, our volumes are dedicated to and belong to a particular SVM. So if department A has got volume A, it's owned by department A and department B cannot see it. Our other resources that are dedicated to and owned by an SVM is the namespace, the directory structure of that SVM, the IP addresses, which are on the logical interfaces, and also the departments, the SVMs, can have their own separate dedicated administrators as well. So there's department A, and then we configure a separate SVM for department B. Department B will have its volumes, it will have its namespace, its own IP addresses, and it can have its own administrators. The way the administration works is our department A administrators can log into the department A SVM and manage their resources. Department B administrators can manage department B, but department A has got no access to department B. Department A administrators can't even see that department B exists. For adding new SVMs and for managing the system as a whole, we also have administrators at the cluster level. If in your enterprise you don't need to configure separate logical storage virtual machines for different departments, then you will still have at least one SVM which will be used as the default location for your data. SVMs are also very useful in a cloud environment where we can have separate SVMs for different customers. Okay, so that was just a basic overview. We'll be covering all of that in much more detail later on, but that's all you need for now. See you in the next lesson.